Hello everybody. How are you today? Good morning, good afternoon, good evening, depending on where you're joining today. I hope you had a great day or it starts as good. Okay. Well, thank you all for joining, first of all. Today we're going to be talking about developing small PV plants, advantages, challenges, and optimization from the developer point of view. Okay. So we're very on time. However, the first minutes are going to be slow, so hopefully we can have also more people joining. But let me go ahead and start. Today it's going to be myself and my colleague Ming. She's the technical advisor, solo design engineer in the Australian and East Asian markets. And myself, I'm the senior account executive of Oceania. And yeah, we're gonna discuss this topic. Let me go ahead and present you pvDesign to just briefly. Actually, an idea here to have all of your attention today. We would like to launch a poll question, and it's to see of all of you, how many might have used pvDesign ever. So let's go ahead and launch that poll for a second. And while you answer that question, the slide that we were seeing before, I know it by heart, so I can continue with it. But basically, we are a software that we are present all over the world. We'd like to say from Chile to China or New Zealand to Canada. We have more than 2,600 users, recurring users every day using our platform to develop more than 11 terawatts per year even. And overall, we have more than 3,050 customers. Okay, with that being said, we have some of your votes. I'm really happy to see that we have 33% that actually tried it at some point, 22 use it often, that's amazing, and at least 50% that have never used it, seen it, and we're happy that you're here today because we're going to show you some really important parts. Okay, let's continue with the conversation today. So this is going to be our agenda. We're going to start by a market overview, then we're going to discuss some advantages and challenges, and then my colleague Ming will continue sharing her screen, showing pvDesign, and talking about small plant optimization. Last but not least, we will go over some questions, and you're gonna see, I don't know exactly for you where is it, but you have some questions down on the right, and you can ask any questions at any point, and we'll review them at the end. Okay. Okay. Let's start with a market overview. First of all, I wanted to show you this information that we carried out. This is our trends report. We do it annually. We gather some information from pvDesign. It's quite interesting. And also we ask experts on the industry. These were the results of more than 100 responses. Interesting, grid saturation and permitting and regulation are the biggest challenges of the renewable sector today. Okay, 64% responded that both of these are actually the main challenges. These are followed by others too. Actually, the percentage diminished a little bit comparison to 2022, probably because other challenges increased a little bit, such as, for example, emergence of difficulty difficulty to find skilled personnel, increased cost, or just intermittency of electricity supplied to transmission grids. In the end, it makes it difficult for operators to balance power flow, right? So definitely the rapid development of renewable capacity is key, right? So that's what we're going to talk about today. And actually, of that trends report, I would like to show you a quote from one of our colleagues, Lucio Paiva, from Casa dos Ventos, and he did say, and I think he quite has a point here, that investment in transmission infrastructure and storage will allow for more renewable energy penetration on the grid, thus lowering energy prices. Okay, so after that, another thing that I want to mention, it's a topic here today, right, is how smaller plants can ease these grid connection compared to larger farms while face far less red tapes and delays. both of which can add substantially to the cost of a project, right? So actually, depending on the market, you have different rules and regulations to develop solar plants, usually involving bureaucratic processes with different lengths and all kind of financial aids, right? From my experience, I know, for example, that in Australia, generating system connected to the grid of less than 5 megawatts is totally exempt from registering as a generator in the market, which releases developers from a massive regulative challenges, delays, and costs, right? But this is not only in Australia, this happens basically everywhere. For example, in the Nordics region in Norway, plants that are smaller than 1 megawatt have more ease in the knock of the government to connect to the grid. And in Brazil, similarly, renewable distributed generator plants, including not only solar, but any other sources, right? And we're talking about hydro, biomass, whichever, in a ranging between 1 to 5 megawatts, not only also have easiness to connect to the grid, less bureaucracy and authorizations, but also they have incentives, right? And this is also something that happens in the US. It's incentives for these smaller plants. And in France. In France, actually, it's being quite considered. Not only we're talking, for all of those that don't know us, we're experts on utility scale, but in France, they also have these incentives for panels on top of rooftops, parking lots. Poland, Italy, we're looking at the same thing, right? For these smaller PV plants. So having said that, let me go ahead and show you some statistics that we pulled out from pvDesign, also to back up this notion, right? And what we can see is that we study all of those projects that were done before, below 2 megawatts and also between 2 to 5 megawatts. And this was surprising because of more than 4,000 simulations worldwide only last year, okay? 10.5% of the total were done in this range, which is huge because it's a very small range if you think about it, right? Other very common regions of development in pvDesign were from 15 to 50, of course, from 50 to 100 megawatts. Those are quite common, but having 10% off from 2 to 5 megawatts, that's amazing. And if we see the different countries, we can see also that in Norway it's bigger, in France it's quite big. That partially makes sense because in Europe, the grid, the land is even more restrictive, right? But in Brazil, US, or Australia, plants tend to be quite big. And we still see a big percentage of these plants that are within this range. So interesting. And also, actually, we looked into these percentages and how it has changed in the last years. And we've seen that in 2021, we were in a 7.5%. In 2022, we were in between 8 to 9%. And now we are already in 10.8 this last semester. So increasing trends for sure. Okay. Let's talk now about advantages and challenges. Just really quickly, and quite basic, right? The advantages that we can see of these smaller plants is, of course, the easier grid connection, which will reduce project delays and costs. Also, smaller plants mitigate the social impacts and rural skepticism, something that we've seen growing. And in the end, all of this will provide an easier finance access. As for challenges, these smaller plants also find sometimes more difficulties in the topography part. Restricted land areas too, you're gonna have more interesting designs and layouts, let's say. And also we need to be careful with the capacity because, for example, in Australia, systems that are artificially held to less than 5 megawatts by software controlled power limitation would not apply for these exceptions. So there's a lot of things that we need to take into account, but overall, there's a lot of unused wasted space, let's say, from farmlands or idle rooftops, which if we transform them to powerhouses of clean renewable energy, well, it could be interesting and cost effective, right? Okay, I think that's it from my side. Now my colleague Ming is going to go ahead, share her screen and show a real project, a small PV plant. Before we do that, however, I wanted to launch a new poll while we're doing this transition. And it's basically, if we're going to launch it now, do you actually develop this type of smaller PV plants? If you can go ahead and answer that, we'll give the answers in a second. And yeah, Ming, if you want to go and take the lead, the floor is yours.
Perfect. Thank you so much, Laura, for the great presentation on the topic. And I just want to introduce myself again a little bit. So I am Ming, and I'm a technical advisor at RatedPower. And from now, it's my time to show you how you can actually design smaller versions of the solar plants on pvDesign. While we're doing the polls, let me just quickly share my screen. Okay. Sorry, just 1 minute. I'm having a bit difficulty of connecting to the screen right now. However, our poll is in progress and we've collected a few responses already. And 81% of our audience are saying that it is 82 now in their main work. And about 12% of our audience haven't really considered it before. So this is great. Since we do have a lot of people here that could actually benefit from today's webinar, because we will dive into pvDesign and show you how our software can actually equip you to develop small solar plants in a smarter way. Okay, so now I have the control. Let me show my screen.
Actually, Ming, I think we had our cameras off. I think that's real.
Great. Sorry, Laura, are you seeing my screen? I can't really see it here. Perfect. All right. Okay. So first of all, while we're at the login page of pvDesign, just please allow me to recap a few takeaways from this incredible speech that Laura has just given. We know that smaller size of PV plants has its own advantages, such as the ease of application to the grid, reduction on the delays and costs, and sometimes we even get incentives to develop them. And as a SaaS company, pvDesign is improving always according to our users' needs. This year especially, we have released some features that could actually uncover a smarter way for you to develop smaller size of PV plants with more accurate results and more optimized design, and make it more reliable for you and your team. So right now we're at the login page. As always, with the email and password, you can log in despite what device you're actually on. And we're at the interface of the software. I would dive into the projects that I've prepared for today's webinar in a minute. Meanwhile, I encourage you to always actively participate in the Q&A and send any question in the chat so that we can discuss and address at the end of this webinar. And also, at the end today, I hope you have a solid understanding of the steps you will need in pvDesign to develop your small solar plants, smaller size of solar plants. Okay, so I have prepared a project folder for today's session. By clicking on that project, I am in the project folder right now. I am giving the details because I do understand a few portion of the folks today are not very familiar with the software. So please bear with me for all the details I'm giving. Right now, I'm at the project folder, and we're looking at several designs that I've prepared for today. They are completely different. So if we look at them from the webinar small PV1 to 4, we have 4 independent small size of PV plants. Their size vary from 3 megawatt DC to around 7 megawatt DC. And if we look at the size of the sites, they're around from 4 hectares to 9 hectares. And I think that suits well with today's topic. We are considering how pvDesign can help you to develop the smaller size of PV plants, not only considering the capacity, but also maybe complex terrain or a portfolio of different small sites that are actually connected to each other. So let me introduce you to the designs that I've prepared one by one. The first one is located on the pretty flat terrain. And I was imagining myself as a developer. I'm looking at a range of the sites that has potentials for me to buy land and develop my own solar plant together with my storage system. And I'm looking at the first plot of land, and it's around 7-8 hectares. Right now, I have clicked on the design, and it's bringing me to the detailed design page. Excuse me. We're looking at a flat terrain without many difficulties such as trees, shadings, etc. It looks like a perfect land, actually. So I have actually given some fixed structures to start with this land. Here I want to remind that we do webinars pretty regularly. And last year, Laura and another colleague of mine have done an incredible webinar, which is talking about which structure is the best for narrow or smaller lands. And the conclusion from that webinar is fixed structures actually give you a lower LCOE for smaller sites. So today I'm using fixed structure dominantly for all of my 4 plants. All right, so that was my first plants. And then the second one, I'm looking at a small site, triangle shape, with quite a bit of shading. So in pvDesign, we have the feature that allows you to circle out the restricted area that's not suitable for structures installation. In that case, I've circled around, for example, a few trees, and on the east side, I have some more a line of trees. On the south side, I have also a line of trees along the border of my site. And also I have circled around the infrastructures on the site, on this plot, that we're saving for future use of other things. And of course, I'm actually connecting it to the same substation we're considering for the first plot. Okay, and I will go back and show you the third PV plant I have developed. And the special thing about this site is that you actually have a river going across the sites that I'm choosing. And I used the same strategy. I have circled it out with the restricted area. And I developed this site within the same available area. However, I can also divide the area into 2 to look at the west parts and east parts separately. And we can give them different inputs, for example, different pitch distances or different azimuths to actually optimize my single design in the end. I will show you that in the last design during our design procedure in a minute. Okay. So that was my third one. And the fourth one would be a land in the south range, in the south of the range that I was considering, this land is actually quite simple. However, it does include a public road that's actually crossing the land itself. So in this case, I have enabled the shortcuts function in pvDesign, and I've just simply drawn a line feature across it. And now you can see that the software is considering the public road that's pre-existing as my internal road in the future in the land site. All right. Okay, so that was all of my 4 solar plants. I have simulated them individually in different designs. And finally, I have also combined all 4 plants together to develop them as, for example, a portfolio of mine. I actually want to include all 4 of them in my future investment. And so I have developed them in one single design. And now I will jump into the design procedure to show you how we actually optimize and do the smaller size of plants. As you can see, we are already loading all 4 sites that I've introduced earlier. And I want to show you the 4th site specifically because I have just divided them into 2, the west one, the west bank of the river, and the east one. And if we look at the layout tab, the software actually released this new feature last month, which allows you to have completely different configuration per polygon or per area. Let's take this one as an example. We have a polygon 4 and polygon 5 on this site. And we can give them different power requirements. For example, for AA polygon 4, I can give it a specific power that I'm thinking about. Or I can also go with maximum power for the maximum use of the land. And then specifically, I want to change a little bit. For example, I was actually considering this site as an agri-PV example. So on the west bank, I don't see any animals there, so I probably will shrink the clearance between the structures or the pitch distance, if you're more familiar with that. And you can see that the software immediately gives you a better optimized design for the layouts with shorter pitch. And on the east bank, I'm going to keep it even wider for the animals to run through the passages. And I will just quickly switch back to the structure type that I was using. You can see the minimum ground clearance that we're considering for our structures. So in this case, in order for my animals or the herds to live freely, I'm going to increase the minimum ground clearance of my structures to 2 so that they can run freely on this land. And also, I've circled out the restricted area for their water ponds and their barn. I think it's a pretty genius of the idea that I'm creating this agri-PV in New Zealand. And then we have another new feature that's released last month, also dedicated to smaller size of land, which is with full parameter road or minimum parameter road. In this case, for example, for case 4, I'm gonna go, and also another option, no road. In this case, I will allow no roads since the clearance is already enough for me to do normal maintenance or access to my power stations. And in this case, we can actually utilize more land without giving spaces to the roads that normally we're considering for the bigger size of plants. Finally, another highlight is that we have partial structures. In case you're considering a long structure, in this case, 20 meters long, for the majority of your site. Now you can combine different sizes of structure. For instance, this case, the shortest I'm considering is around 7 meters. in this case, I can utilize the most narrow land or the corners of the blank spaces. And finally, the last one that we have released about 2 months ago is grouping areas in the low voltage system. Let's see these two areas that are actually adjacent to each other. Instead of connecting them on the medium voltage level, we can actually click on group to share the power station's capacity and share low voltage system. And in the end, we can have a more optimized electrical configuration on this land. Once I have done that, of course, I can go into other sites also to adjust the most optimized parameters, but I will skip them. And I want to introduce you that we actually, since we're combining all four, we're having quite a higher peak power. And I'm connecting to the grid with the overhead line function that pvDesign provides you. We will calculate and give you a very detailed overhead line report and design in the end. Well, of course, together with my battery area here, we also will consider the storage for this entire portfolio. After all the steps are cleared, and I can generate the design for this combined area. And once I have clicked it, the simulation will be running on the cloud. And this has nothing to do with the computational power with your device. This result should be showing in less than 1 minute, and you can actually acquire. I will just go into this old design. More than 400 pages of very detailed engineering, energy yield, and cost-related reports, spreadsheets, and drawings. All right. That's all for my presentation of the pvDesign with a smaller size of PV. Okay, so I will actually show the Q&A page, and we can enter the Q&A session right now.
Perfect. Thank you, Ming, for that. Do not close pvDesign, I would say, because hopefully we'll have some more questions about that.
Sure.
We actually have a couple already. So the first one is the software a standalone or a CAD add-on? And the next one actually is going to be more for you. I think I can go ahead with this one.
Sure.
It is a software standalone. It's not, you can download documents in CAD, but you do not work in CAD. So it's a software standalone. The next question, can we add inverter locations, string designs? That's the next question.
Right. Okay. I'm actually having problem of showing this slide, so I'm gonna switch back to pvDesign, which is perfect. Yeah. So in terms of the inverter locations, we actually automated for you, depending on the the shortest electrical configuration, the cable size, the cable length, and the best block of structures layout. So that if we zoom in, you will see the power stations are located in normally the center of the blocks. That's for the power stations locations. For inverter, especially for string inverters, the software will also automatically do it for you. We actually can see it in the AutoCAD drawing if we download the general layout. On the preview page right now on the website, we are not able to see where the string inverters are located. However, we can see how the string cables are running. So basically, the string inverters will be located on the side or the edges of the structures. And also, we still consider the most optimized cable length in that case. Okay, I see 2 more questions coming in. I will go ahead. Is there best design functionality? Yes, we actually included a battery storage system in this design. So I will just enter the design phase to show how pvDesign can give you a best design. In the best design page, the users will be able to select the power conversion systems that they want to use by selecting a storage inverter first, and then choosing how many inverters of the capacity they want to include per power conversion system. And these will be indicated in the green boxes on the preview of our layout. Then the users can choose battery containers. They can either choose the kilowatt hour of the battery container or choose the kilowatt hour of the racks and how many racks they want to include per battery container. And if you calculate by the units of the racks, you will also come into a total energy capacity for each of your battery container. Once you have selected the battery container, the software will ask you what's the power or the capacity you want for your battery area. You can either maximize the land use, like in this case, we're installing as many battery as possible, or you can give a specific capacity for your site. Normally, I see people consider 10 to 20% of the entire peak power for the consideration for energy storage. So in this case, we're considering, for example, if I consider 2 of the PCS, I'm actually considering about 10% of my peak power. So I think that's a good portion for my energy storage system. Then I can select how many hours I want to charge-discharge per battery. And for example, if I choose a higher one, 5.5 hours, that means per day I have 5.5 hours for the batteries to do the charging and discharging. If I recalculate my layout, you will see that the software will give me exactly 2 power conversion system that I have asked for, and corresponding to each, I have 3 of the 2,000 kilowatt hour of the battery to get the electricity from my power conversion system. In the end, you can also decide some dimensions for your power for your best system, and also some setbacks or distances between blocks or the batteries here. So with all that I have defined, I will come into the conclusion of a good battery design report, and it will also be available in the bill of quantities. For example, how many batteries I need, how many cables, what cables I'm using for this battery area. And then finally, I also have the layouts and the single line diagram for it. All right, I hope that answers the question. It was from the design to the results. I have introduced all. So I'm gonna go with the next one. We actually have many more questions to cover. Is there a specific price plan for the smaller PV plant? In terms of the price or the CapEx template, we do provide some public templates for the users that we extracted from IRENA's report. This is, however, depending on the region or a country in the world, varying from 2019 to 2021. We do not, however, vary this depending on the size of your plant. So if you want to develop, for example, in that case, in Australia, you can use the templates that we have prepared for you. We do encourage the users to clone the sheets and build their own CapEx sheets, which is more recent and matching better with your suppliers or the market price. And this is our CapEx creating page, where you can add freely the category, subcategory, or the entries And more importantly, you can match each item to the units that's exactly corresponding to the bill of quantities you're getting for each of your design. For example, in this case, you can select how many modules instead of the main peak power. And for example, for the cable wiring, you can actually select how many cables, how long your cables are for which cable. And then you can put the unit price for that cable to have a more accurate LCOE in the end. Okay, the next question. As a developer of rooftop projects, I often encounter various designs influenced by the engineer's preferences. To ensure the best selection, how does pvDesign validate and determine the most suitable design among these options? All right, so if you want to figure out which is the best design, you have to try our a comparison tool. This tool can give you all the results in one sheet, and you will be able to see yourself which is the best design. So I have selected all 6 designs that I have simulated in this project folder. And by clicking on compare, it brings me into the comparison view. And I can actually filter with the metrics that I'm interested in. For example, I will choose GCR, pitch, and PR. And then you will see among these 6 design results, which is the best design results. The software will highlight it automatically for you. For example, among 6, I am seeing number 11, which is actually my 4th, the agri-PV plant, has the highest specific production and the best performance ratio. And of course, the lowest LCOE because they're interconnected. However, if we want to consider how much of the energy we're getting per year, of course, the combined one will give us the most because we're installing the most structures and the highest peak power there. And you can also view it in the chart view to see how exactly they're varying from each other. For example, the cost, the energy yield, etc. So to answer your question in short, you can use our comparison tool. Oh, I just remembered another tool, which is batch design, where you can generate up to 10 different pitch distances or 10 different DCC ratios for your design. And these 10 or up to 10 designs will run parallelly simultaneously, and you will get the results in one time. And then you can use a comparison tool to compare. Here, I just want to give you a little spoiler. Actually, we're releasing a new feature very, very, very soon, which is another function for batch design. We will have the tilts for batch design. So you can simulate different tilts at one time and see what is the best tilt for your design. Okay, so that is the how to get the most optimized design across the board, like between different engineers. You can actually use these features to help you make a fast and accurate decision. And then finally, a follow-up question: can we export the comparison report? For now, the users cannot directly export it yet. Sorry. If I go back to the comparison page, for now, the users cannot export directly. However, there's a small trick. You can actually copy the entire page, the web page, and copy. And in Excel, you can paste it. And it's actually very easy to edit. You can edit them item by item, entry by entry in Excel sheet. Before we actually have the feature of exporting. Another spoiler, we are developing that feature right now as well. I can't tell you as the last feature about the releasing dates yet. But I do know that the tilt batch design is coming very, 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 very soon. All right.
I think that was our last question for now. I don't know if anybody else has any questions. Don't be shy. Thank you for all of these questions, by the way. They were great.
Yes, thank you so much.
I hope you enjoyed it. For all of those 50% of people today that has never used pvDesign, you can always request a demo and you can use it. We encourage you to do it. And for all of the others, just reach out whenever you want if you have any questions or need to have any more explanations. Who's the best contact for demo and pricing? You can log in on our webpage. There's click in, request a demo, and that would guide you directly to the account executive of your region, which could be different. So just click on that and we will inform you on all of that.
Yeah. Also, there's another question here. When will you release the grouping of users in teams? So I'm not very sure what exactly you're envisioning about this feature. Another spoiler, we are studying on this, the authority of the user level and how to management better in the company. Actually, we did release this feature, I think, a few weeks, maybe 2 weeks back, where you can already check the statistics and KPIs for your company, and you can see where your projects are going on, what's the size of them, and how the designs look like, where the sites and what's the size of your size, what's the activity of your users. This is good for the managers, and also what equipments are actually favored or preferred in your company. So we have this feature released 2 weeks ago. We are actually studying on the user level things. It is already been a long-going project internally. We want to have this feature as soon as possible. For example, you said grouping of users, etc. But we might still have to wait for a while. With your question, though, I will also bring it back as a feedback to our development team. And if you want to talk with us more, always feel free to contact us, our support team. You can get in touch with us on the interface, or if you're not a user yet, you can go to our webpage of RatedPower and contact with us and let us know what you think of the software and how you want it to develop.
Perfect. Well, I think that's it for today. Again, feel free to reach out by email, and we are happy to join on to another call and explain any other thing that was left. Thank you for joining today. Ming, I don't know if there's any other thing on your side or...
I think that's all, and I just hope today we have equipped you well enough on pvDesign with the tools and knowledge to start your first smaller PV plan design. That's it.
Perfect. Thank you, everybody. Have a good day, evening, or wherever you're located. Have a good time.
Perfect.
Bye-bye, everybody.
Thank you. Bye-bye.